Now, the NAT clearly violates the end-to-end principle because machines behind the NAT are not globally addressable or routable, and other hosts on the public internet cannot initiate inbound connections to these devices behind the NAT. Now, there are ways to get around this. There are various protocols. One is called STUN, or Signaling and Tunneling through UDP-enabled NAT devices. And in these types of protocols, the device sends an initial outbound packet somewhere simply to create an entry in the NAT table. And once that entry is created, we now have a globally routable address and port to which devices on the public internet can send traffic. Now, these devices somehow have to learn that public IP address and port that corresponds to that service. And this might be done using DNS, for example. It's also possible to statically configure these tunnels or mappings on your NAT device at home. Needless to say, even with these types of hacks and workarounds for NAT, it's clear that network address translation is a violation of the end-to-end principle because by default, two hosts on the internet, one in the home network and one on the public internet, cannot communicate directly by default.